As you guys are writing, I'm going to go ahead and get the video caught up a bit. So I just got it on my iPad as well. So remember in the very beginning with our warm-up example, what's showing on the screen right now, for me, but not for you. Numbers 1 through 8, it was manageable for us to actually think through these numbers 1 through 8, to think about the different pairings that could sum up to 12 with our 4 and 8, 5 and 7, and 6 and 6. It was somewhat manageable for us to think about how that could be ordered different ways with the 4 and 8, or the 8 and 4, the 5 and 7, or the 7 and 5, and the 6 and 6. It was manageable for us to count them all up by hand, to think of the options and then add them. We talked about the different terms at the beginning of 9.6, how the goal of this entire section is to be counting up the number of favorable ways that something could actually occur, but not necessarily the total ways something could occur. But if we can't do the old-fashioned counting up, listing and counting them, we need other principles. And what you guys are writing right now is the very first one, the counting principle. We're also going to see some formulas for permutation combination, because some of you guys already know it has to come up in probability. It is a big deal. Where does that get found in your calculator, by the way? Good, math probability. Didn't we already have to get there for factorials? And didn't we already use NCR for something that didn't seem to be probability? The binomial theorem. Then we did a quick example for the numbers 1 through 12. Once again, it was countable in order for us to think about how many different ways can a computer choose one number divisible by 4. It could be 4 or 8 or 12. There were only 3 possible, and it was only choosing one number. There were no other ways of arranging it, either 4 or 8 or 12, 3 different ways. 2 distinct integers, though, were a little bit harder in getting what we have. 4 and 5, or 5 and 4. One combination of numbers, because it's just the numbers 4 and 5, 2 permutations. We had 3 and 6, or 6 and 3, 2 and 7, 7 and 2. What was the last one? 4 and 5, 3 and 6, 2 and 7, 1 and 8. 8 possible ways. Thanks, kiddos, for letting me catch up on the video, especially for Jane and Cameron and others who might need to watch it. Let me go ahead and unfreeze the screen and let's get back to where you guys are. So, our first trick. What if things are just getting a little bit too out of hand? That never happens in life, right? Just kidding. What if things are getting a little too intense, a little too out of reach in order for us to count up, especially with our lack of grit, to count up all the different options and then to come up with all the different options and then count them? Well, one key word that we need to always keep an eye out for, especially in probability, is the word and. Later on, when we get to section 9.7 in actual probability, we'll talk about how the word and goes together with intersection, the term, the vocab in math, intersection, or goes with union. But for right now, all we need to kind of put together with the word and is multiplication. To put together with the word and is multiplication. And let me give you a quick example. What if, before we get to the one below, what if, I'm going to go off to the side. What if we were trying to think about the different ways that you could pick out an outfit for coming to school this morning? Okay? Do you guys have some? For some of you that might be almost true. But, coming back, we're saying that it's definitely limited, right? If you're trying to pick an outfit, you have to stay within uniform. Supposedly you're supposed to. Number 1. Number 2, there are certain components. Let's just go for the main ones. So we'll say what top you choose. We'll say what bottoms you choose as far as like shorts, pants, or girls' skirts. Guys, I guess that's not an option. Shouldn't be anyway. Then coming back. And then let's say, I don't know, shoes. Let's say you typically have 2 different pairs of shoes that you wear to school. Some of you still, it's like one for all of those. But let's just pretend. Let's say because of circumstances or because of money or because you just don't really want to have more school stuff than you have to at home. Let's say you have, I don't know, how many pairs of, let's just say pants, and we'll just say that includes shorts, whatever, uniform bottoms. There you go. How many do you think is reasonable to have? Two. Okay, sounds good. So we have 2 uniform, and I'll just call them pants just for sake of illustration. 2 pants, although no one really wears pants. Just kidding, not no one, but few. We'll say shorts. That's somewhat not gender specific. How many tops? We're assuming laundry was just done.
So
5?
maybe 4.
Well, we are on a Wednesday. Let's say 3. Does 3 sound good? Okay. So 3 tops. Look at you, planning ahead. And then shoes, I said like what, 2 pairs of shoes? I'm being generous. I know, I'm just trying to, you know.
Yeah.
No, we're not going too crazy. We're not going too crazy. Okay. Question, kiddos. How could you come up with the total number of different outfits that you could have worn today?
You draw pictures. 2 shirts.
No. I don't mean the number per se, but how could you come up with all the different options? What's one strategy of coming up of literally all the different options? So let's say that we had something like, what are acceptable colors of tops? We'll do blue, black, gray. Okay, blue, black, gray. For shorts, let's do 1 pair of pants and 1 pair of shorts. We'll just do that. And then for pairs of shoes, we'll say, oh, you can't wear sandals. That's sad. Black shoes, that's pretty normal.
And Uggs.
And then Uggs? Is that a thing?
Please no.
Let's do black and let's do gray for those also, but let's go ahead and use a little B and a little G. Okay. I'm just trying to show you guys why multiplication. I know you know it's multiplication, but why? Okay, the very first thing, let's just say you're picking out your shorts first, okay? So you can either pick out a pair of shorts or you can pick out a pair of, sorry, I said it backwards, a pair of pants or a pair of shorts, right? Okay. Once you've picked ones of those, don't each of them, if you pick pants, don't you then have to figure out the tops with the blue, the black, or the gray? And for the shorts, don't you also have the option of blue, black, or gray? Does that make sense? So one possible choice you could take is the pants, and then you wear the blue shirt, right? But aren't all of these possible combinations, possible outfits, I should say, that you could choose? Yes. Now, as soon as we bring in the shoes idea, what changes? It expands even farther, because once you've chosen the pants and you've chosen the blue shirt, now you still have the choice of what? The blue shoes or the gray shoes. But wait a minute, if you take this outfit, don't you have blue shoes or gray shoes? This outfit, don't you have blue shoes, gray shoes? This outfit, blue shoes, gray shoes? This outfit, blue shoes, gray shoes? This outfit, blue shoes, gray shoes? Took me a little while, but question. You guys said multiply. I said why. Do you guys see why?
Yes.
Because if you have 2 different options for pants, and then each of them are going to have the 3 options for shirts, 2 times 3, there are 6 options there. And then out of those 6 options, if you then also need to pair with each one 2 pairs of shoes, then those 6 are now going to be multiplied by 2 or 12. So if I'm doing 2 shorts and I have to choose 1 pair of shorts out of 2, 1 top out of 3, and 1 pair of shoes out of 2, yes. 2 times 3 times 2, 6 times 2, or 12 are going to be the number of options. Now, long story short, do we want to actually show that diagram of putting everything together every time? And the answer is no, right? We don't want to show that diagram. But does it at least kind of make sense why multiplication? It's kind of helpful not only to say whatever and multiply, who cares, but to realize every time there's another option added, it's going to keep branching out, branching out, branching out. Multiplication is the way to go. So how do we apply that to this example? How many different pairs of letters from the English alphabet are possible? Could I write out A and B and C and D and E and F and say, hey, these are all my different possible first letters? But then A could be paired with what letters? A or B or C or D. Do I actually want to write this out? Oops, that was E. And F? How many options would I have here if I kept on going, dot, dot, dot?
26.
26. And how many options would each of the 26 have? 26. Struggle. If each of the 26 letters have 26 different possible second letters, then how could I do this? Oh, easy. Just say how many options for the first letter times how many options for the second letter. 26 times 26, there was no crazy complicated flowchart thing that we had to make. Our final answer is, can we just cheat and say 26 squared? Yay! 26 squared different pairs of letters. Now, here's something that's a little tricky. We talked about pairings, just describing the numbers that would go ahead and make the sum of 12 or the sum of 9. Pairs of letters, guys, whenever you see letters, order is important. Whenever you see letters, order is important. Whenever they're being put together to make words, but don't worry if some of the pairings don't make actual words. It's not like you're playing Words with Friends or Scrabble. You have to check in the dictionary to see if it's an actual word to make you any points. You're just trying to think of what are the different options I'm choosing from. What are the different ways of putting these letters together? And as we know, in words, the arrangement of letters makes a difference, right? Lucas, hood off, bud. So, how do we apply fundamental counting principle? You can think of each situation as separating each part of the event, and the and means multiply. How would you guys do this one? Take a second, write down the important information as far as this license plate, or this type of license plate. Oh, sorry, calculus kids turned on my lights this morning. It's really bright in here, I just noticed.
It's not always like this.
No, it's always like that. I feel like we have this discussion almost every week.
You do?
We do? I don't know.
Maybe I don't notice it in your guys' class. Maybe I notice it in period. Probability. Remember, you don't have to write down big paragraphs as you're doing the questions in your homework. You're trying to summarize what's the big idea. What are the most important characteristics? Parameters, specifications for what's being given.
Do we have homework?
Oh, I didn't write it. Sorry. Calculus kids needed help this morning. I got distracted. I don't remember the number. Do you guys remember
Well,
where
you
we
put
ended?
9.1.
That's not 6.
What homework number are we on, kiddos?
50.
Okay. None of us remember by heart.
Yeah, me either. See, that's a struggle.
57.
I took the job up. Great.
57?
58.
58. All right, what'd you guys come up with? It depends on how today goes. I hope it's tomorrow, but we'll see.
It worked out.
Don't tell me an answer. Tell me the pieces. What pieces did you have to think of? What were the restrictions? What were the parameters? What had to be true? Okay, so first of all, 2 letters, 4 digits. You can think of 4 digits as, even though you can think of them as the numbers from 0 to, why am I saying 9,999?
It's the highest.
That's the highest you can go and still have 4 digits. If I go one more, it'd be 10,000, and how many digits is that? 5. So all the numbers from 0 to 9,999, but you can also think about them as 4 separate single-digit numbers. You can also think about them as 4 separate single-digit numbers. Restrictions, what are we not allowed to use? Only O and I. We can still use 0 and 1, right? O and I are not used. All right, how do we do it?
Multiply.
Multiply what?
24 by...
Okay, that is one way. We can go ahead and think about this as each of it separate. Like, hey, there's one letter. That's it looks like a decimal point. One letter, another letter, and then we have 1 and 2 and 3 and 4 single digits. So here are 2 letters. Here are 4 digits, literally separated. And why'd you guys say 24 times 24?
There's 2 letters.
Yeah, it's 26, take away the O and I. Still have 24. 26, take away the O and I. 4 digits. Jason, how come 10 and 10 and 10 and 10 and 10? 0, 2, good. To be a single digit, you have to think of the numbers 0 to 9. So there are 10 of those, 10 of those. They don't say nothing can be repeated. So therefore, we're good on all of them. Why couldn't you use permutations on this example? Order is important. License plate, switch things around. It's a different license plate, right? Why can't we use? We have 2 separate things, letters and digits, and also, do we have a finite number of objects, meaning, can digits be repeated, yes or no? Can numbers be repeated?
Yeah.
Yes. Can letters be repeated? Yes. That's why we can't use permutation. Permutation deals with fixed amounts in the sense of you only have 24 objects, you're choosing 2 of them. Now, could you do 24p1, 24p1, 10p1, 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 10p1? I guess you could do that, but 24 times 24 times 10 times 10 times 10 times 10 sounds a whole lot easier.
So combination can be repeated?
No. Combination is with a set number of objects as well. When you take away one, it counts down how many options are left.
So Crawford was right when he said we have a locker permutation.
But combination pizza is correct. Just not locker combination.
What's combination pizza? Is that just like toppings?
If you order a pepperoni sausage pizza and get a sausage pepperoni pizza, did you get the same combo pizza that you wanted?
Yeah.
But they put the toppings on in the wrong order.
No one cares about that.
Exactly. Combination
Let's go.
pizza. Okay. What happens if we go to numbers? What do you guys think we're going to do for each one of these? Why am I drawing 3 blanks? Think about each of the single digits. As Jason said, single digits are the numbers 0 through 9. There are 10 different options. Why wouldn't this one for letter A, why wouldn't it be 10 times 10 times 10? They do a restriction. Numbers can be repeated. The last digit can be any of those 10 options. The second digit, the tens digit, can be any of those 10 options. But the leading digit can't be 0. So how many options do I have for the leading digit? Just 9, which would be 900. And guys, does that make sense if you're thinking about all the numbers, 3 digits? Let's see, isn't that 0 to 999? Because 1,000 would be a 4 digit. But which of these numbers would you have to take away if the leading digit can't be 0? From all the numbers 0 to 999. If the leading digit can't be 0, what numbers are now eliminated? 0 to 99. How many numbers are those? 100. So from 1,000, take away 100, you get 900. There are more than one ways to think about this problem, but fundamental counting principle is a good one. And letter B. Did Jacob remind you? Good job. How would you guys fill in B and C and D? Let's see what you guys can do on your own as I get the test ready. Think about your 3 blanks. Think about the number of options that are legal or possible for each. We'll check and see what you guys were able to do as soon as I pass out tests. Will you hear your name? Come on down and grab it. Not the one we took yesterday. The chapter 8 HRC one. Ready, set?
For C, is it the whole number is multiple of 5 or the leading number?
The whole number. My A is your first in no particular order. Alex, Austin, Yvette, Maddie Garcia, Jesse, Ricky, Nathan. Nathan, Sam, Ashley, Mason, in no particular order, the rest of you guys really did really well. Just those were the only A's. Emily, Jason, Elaine, Lucas, Jacob, Justin.
Maybe she forgot mine. Maybe she
No,
forgot
Caleb.
Maybe mine's just at the bottom.
What?
Maybe she left it on her desk.
Bayla, Naomi, Denise, Abby.
Oh, I mean, no, I didn't say it.
Shut down.
So Ricky.
Maddie,
Oh,
Caleb, Tyler,
Hello.
Nadia, James. Cameron, Mia, Lauren, David. You guys are taking your tests, I'm sorry.
Ricky, David and I got the exact same score.
Ricky and I. No, sorry, Ricky and Tyler and I.
You got 100?
Different strengths and weaknesses came out on this one, kiddos.
So 100.
I think it mostly came down to did you study what we did together in class. But please, go over corrections, we'll have them do next week. Today is Wednesday. Let's have them do next Wednesday. I think we take our probability quiz on Tuesday, if I'm not mistaken. Alright? We take our probability quiz on Tuesday. So we'll make these two Wednesdays so that you guys have the night after the quiz to finish them up. The day after the quiz to come on in and ask me questions if you need to. Do next Wednesday corrections. There we go. What you guys get for the leading digit can't be 0 and no repetition of digits is allowed.
9.
Wait, 6? Isn't it 9?
It's 9.
Why is it 998? You're only allowed to have the digits 1 through 9 here, and there are 9 of those options. How many numbers just got used in choosing that place? 1 number. So in this one, we do have 0 through 9 as options, but we have to take away 1 because 1 was used in the first blank. This one, we still have 0 through 9, 10 options, but why do we have to take away 2? 2 numbers have been used in the first digit and in the second digit. So then there are only 8 options left over for the poor little last digit. Did anybody actually solve for that? 72 times 9? 678? Oh, 48. Yeah. Thanks, man. My mental math went off. For the next one, still a 3-digit number. What'd you guys figure out? The leading digit can't be 0. Well, we know that one. And the number must be a multiple of 5. What numbers are allowed here if it's a multiple of 5? You guys know this? 0 or 5.
Oh, 10 doesn't count.
Yeah, 0 or 5. Remember, just the digits 0 to 9. 0 or 5 can end the number. So only those 2 numbers are legal. Does it matter what's in the 10s digit for this situation, for these restrictions? In the 1s digit of a 3-digit number, in order to be a multiple of 5, doesn't the number need to end in 0 or 5? So this last number can only be a 0 or a 5. There are only 2 options that are legal. If you think of 10, 20, 35, you have to end in a 0 or a 5. 9 options in the beginning because I'm not allowed to have 0, so all the numbers 1 through 9. And guys, are there any restrictions in the middle? No. So how many options are there? 10, aka 180 total. And last but not least, the number is at least 400. This one's kind of hard.
2 10s and 1.
Unless you think of What numbers are allowed in the hundreds digit if it must be 400 or above? Isn't 4, 5, 6, 7, 8, 9? Aren't they all good? If the hundreds digit starts with 4 through 9, aren't we okay? How many numbers are legal then? Any restrictions on tens or ones digit? No. Why does this make sense? What were the legal numbers to begin with? 0 to 99. And they said, hey, it can't be less than 400. So what numbers went away? 0 to 399. 400 to 1,000. Sorry, 400 to 999. 600 possible. Kiddos, if I look at our notes real fast, we still need to talk about permutation combination. That's okay. Homework will be due on Friday. Bye, cool kids.
Why did I get -1?
I guess we can't do homework. Hold on.
All I saw you do was switch the name off of